Okay, so first I want to plot the transient flow or the transient periods. So you see we have these three red dots, and then I plot also the PSS flow, the blue dot. I want to maximize maybe here. I want to zoom in. So starting from, okay, so it becomes bigger, and maybe, or maybe we already satisfied with that. Okay, maybe this one. All right, maybe or not. What about using 5? All right, just to do the zoom in. And this one also 5. All right, and then like this. This one. To 7 maybe. Yeah, we will go with that. So we have the regression using the 3 transient periods. All right, and the last one is the stabilization period. Okay, or the PSS period. But we can start from scratch again. So this one, right click, select data. I want to add the transient period, the X values, the horizontal axis, we use the flow rate, the tree data, and then the vertical axis, we get that from this column there. And then format series, I don't want to make line out of it. And then marker, I want to select this one and then make it a bit bigger. And then for the marker, fill yellow, for the border, red. And then let make this one also for the filling, maybe green, and then the size also big. All right, so that's good. And then we want to do regression, I mean, using this period, the transient periods. So you see the line there, display the equation and the R square. But by the way, be careful. This should be I just want to see. All right, this one, not this one. Regression, right click, trend line, and then, yep, we use power. So you know here, this one, and then let's change it to red, like this, a bit bolder. And we get the equation, make it to 12 or 15. All right. And then let's make the filling like this. Okay, so you get the power there. And this is in the form, or the form of our equation is this one, something multiplied by x powered by 1.0813. All right, and you can change this into linear equation. because here we plot by using log-log plot, right? You can change it to linear equation, but we will skip that. This is the practical way to do that. So actually the power 1.0813 actually is the slope, okay? The slope of this equation. So the equation is like this: the flow rate equals to C multiplied PWS squared minus PWF squared powered by N. Okay, so this is the original form, and of course you can change it to linear form. Okay, but we will skip that step, and you can do the derivation. But long story short, this power is actually the slope. But we need to calculate the N by using 1 divided by the slope. And we get the N of 0.92. All right. So N in our C&n equation, N is 0.92. Right. So maybe I can make the equation here so that we can understand it better. All right. So merge flow rate is C and then PWS minus PWF squared close and then powered by N. All right. Okay, let me make it bigger like this and then make it as subscript and then this one as superscript. Beautiful. And then this one subscript, that one superscript. Lastly, the N, the exponent superscript. All right. Okay, so N is 0.92. N is between 0.5 to 1, okay? N equals to or approaching 0.5 means turbulent flow, and then N close to 1.0 means laminar flow. Okay, something like this. And then maybe 12, maybe 14. Okay. Yep, so to calculate the C, just rearrange the equation.